Morning, students. Welcome back. Today we are going to discuss how the operation amplifier is used to construct averager. How the operation amplifier averages the different input voltages. How it subtracts two different voltages given at the input. The subtractor is also called the difference amplifier. The difference of two voltages. The difference of amplitude of the two voltages, and the comparators, how it compares the input voltage with the reference voltage. So let us first see what is averager. The average amplifier is nothing but the average circuit using operational amplifier, in which the output voltage is equal to the average of all input voltage given in the input. Already we know well that the summing amplifier using operational amplifier. The summing amplifier adds all the input voltage given at the inverting input through the different resistors. It adds in the output. It gives the sum of all input voltages given in the input. It adds the amplitude of the voltage applied at the different input voltages with the negative sign, as it is given in the inverting input of the amplifier. See, this is the circuit of summing amplifier. It consists of operational amplifier here. It is inverting input. It is non-inverting input. It is the feedback resistor connected between the output and the inverting input. The three resistors are the input resistors. The three sources E1, E2, E3 are the voltage sources which supplies the input voltage through the resistor R1. E2 supplies the voltage through the resistor R2. E3 voltage source supplies the voltage through R3. The current passing through the first resistor is I1, second resistor is I2, second resistor is I3. The current drawn by this op-amp is I5. The current passing through the feedback resistor is I4. The power supply is the external biasing voltage, that is, the dual power supply is already connected. The positive is connected to 7, negative voltage is connected to 4th one, and the ground voltage is connected to 3rd pin of the operation amplifier. From this diagram, we know well that the algebraic sum of the current meeting at the point A is equal to 0 here. See here, I1 is passing through this point, I2 also passing through this point, I3 also passing through this point. So it is taken as positive I1 plus I2 plus I3. I4 is leaving the current leaving from this point I4, and also the current I5 is leaving from this point A. So it is taken as negative minus I4 minus I5. So I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Here, the current drawn by this amplifier is taken as 0, that is I5. Why? The operational amplifier has very high input impedance, very high input resistance. So the current drawn by this operational amplifier is taken as 0. So this equation is modified into I1 plus I2 plus I3 is equal to I4. Okay. So here what is I1? What is current? We know well What is current? I is equal to potential difference, that is voltage divided by resistance. See here, the current I1 is passing through the resistor R1. So, the potential difference across this resistor here is E1, that is EMF. Here, this voltage E4, this voltage E4. Therefore, E1 minus E4 divided by the current, the resistor R1. The same way for the current I2, the voltage passing through the resistor is E2. Here E2, here E4. Therefore, E2 minus E4 by R2. The same way, the current I3 is written as E3 minus E4 by R3. The same way, the current passing through this feedback resistor is I4. I4 is equal to E4 minus E output divided by the reference resistor RF. See here, E4 is taken as 0. So due to this virtual ground, the E4 is taken as 0. So in this equation, the E4 is substituted as 0. We get E1 by R1 plus E2 by R2 plus E3 by R3 is equal to minus E output by R feedback. It is a summing amplifier circuit. You know well it is a summing amplifier. This circuit is now modified. How it is modified? See here, there are three resistors R1, R2 and R3. These three resistance values are replaced by the new value. So R1 is taken as 3R1, R2 is taken as 3R2, R3 is taken as 3R3. Depending upon the number of input voltage, the number of resistors varies. So its value also varies. So R1 is equal to 3R1, R2 is equal to 3R2, R3 is equal to 3R3. Now replace these three resistors using this value. See here, the R is replaced by 3R1 here also. So now the voltage E1, E2, E3 is same. The E1 is the EMF applied to the first resistor 3R1. The current passing through the resistor is I1. Number 2, E2 is the voltage applied to the second resistor 3R2. The current passing through the circuit is I2. E3 is the third input voltage applied to 3R3. The current passing through it is I3. So three voltages are meeting at the point A. RF is a feedback resistor connected between output and the inverting input. The third non-inverting input is grounded. The voltage between these 2 points is E4. I5 is the current drawn by the operation amplifier. So now see here this equation, E1 is divided by E3R1, this resistor, E2 by 3R2, E3 by 3R3 and E output by feedback resistor. Now the 3 is taken common and it is multiplied here. So this becomes minus 3 E output by RF. Now take the values of these resistors are equal. R1 is equal to R2 is equal to R3 is equal to R feedback. So we get the final equation. E output is equal to minus of E1 plus E2 plus E3 divided by 3. This equation says it averages. So there are three input voltages E1, E2, E3. The three input voltages are divided by 3. So this type of equation says this operation amplifier circuit working as a averager. So the output voltage equal to the negative average of all the input voltage applied at the inverting input terminal of the operation amplifier. So the value of resistors, the input resistors, or depends upon the number of the input voltages applied here. If there are four voltage source, we need 4 resistors. The value of the resistor changed into 4R1. For 4 input voltage, we need 4R1. For 2 input voltage, we need 2R1. Likewise, we can change this circuit in our convenience. Okay, now we discuss about subtractor or difference amplifier. What is subtractor? It is an electronic circuit which subtracts two different voltages applied at the inputs. It also called difference amplifier. In the subtractor, we use as both inverting and non-inverting inputs to produce the output signal. Which is the difference between two input voltages? We are applying two input voltages. They are E1, that is EMF E1, and E2, allowing one voltage to be subtracted from another voltage. A differential amplifier, a subtractor, producing negative voltage when E1 is higher than E2. The differential amplifier, the subtractor, produces the positive output when E1, the voltage applied to the inverting amplifier, inverting input, is lower than the voltage E2 applied to the non-inverting input. See here, this is the circuit of difference amplifier. You know well that it is the operational amplifier symbol. It is a inverting input. It is a non-inverting input. It is the output. In the inverting input, the resistor R1 is connected. The voltage source E1 is connected here. The current I1 is passing through this resistor R1. In the same way, in non-inverting input, the another resistor with the same value R1 is connected. The another voltage source with different voltage E2 is connected here. So the current passing through this resistor is I2. And a feedback resistor is connected between the output voltage and the output and the input inverting input. In the same way, the another resistor, another variable resistor is connected between the output and non-inverting input. Its value is taken as R2. Here also the current is I1 is passing through. Here I1, here also I1. In this resistor, the current passing is I2. Here also I2 dash. Here actually I1 dash. It is I1, it is I1 dash, it is I2, it is I2 dash. Now we go to the small discussion. The capital E1 is the voltage at the terminal 1 with respect to the ground. See here, it is terminal 1, it is terminal 2. Here the voltage is E1. Here the voltage is E2. This input voltage, so the here EI, I is the input, EI is nothing but the difference of these two voltages. So the voltage at this point and another voltage at this point. Capital E1 minus capital E2. See here, this is the first equation. So, from the circuit, we know that I1 is equal to I1 dash. I1 is equal to I1 dash. So, I1, what is I1? Current is equal to potential difference, that is voltage divided by resistor. Here, the voltage is E1, small e1. At this point, capital E1, the resistor is R1. That is E1 minus capital E1 by R1. It is equal to I1 dash. See here, it is here the voltage EMF is capital E1. Here the voltage E out. So E1 minus E out divided by R2 here. Here the voltage E1 applied is very greater than the voltage appear here. So E1 is very greater than capital E1. So we are neglecting this capital E1 here, but we are including here. Why? For example, if E1 is equal to 10 volts, capital E1 is equal to 0.1 volts. So E1 is 10 volts, the E1 minus 0.1. It doesn't giving any more difference. E1 or E1 minus E1, both are more or less equal. Here we are including E1 because if you are not included, the sign of this equation will change. So we are including even it is a very small voltage, 0.1 volts. We are not eliminating this E1 here. So this equation is modified into small e1 divided by R1 is equal to capital E1 minus E output by R2. Now, so the R1 and R2 is replaced. So this equation is modified into R2 by R1 E1 plus E output is equal to E1. In the same way, I2 is equal to I2 dash. I2 is equal to I2 dash. What is I2? I2 is nothing but small e2 minus capital E2 divided by R2. In the same way here, E2 dash, so I2 dash is capital E2 minus E output divided by R2. Here. Now here also the E2 is taken as 0. So E2 by R1 is equal to E2 minus E output by R2. On replacing this resistance R1, R2 by R1 is into E2 is equal to capital E2 minus E output. We know that the output voltage E output is equal to 0 because the potential difference is added its value, and let us assume the output voltage E output is equal to 0. So this equation is modified into R2 by R1 E2 is equal to capital E2. Now we know the first equation, capital A, input voltage small ei is equal to capital E1 minus capital E2. Already we have derived capital E1 and capital E2. Now substitute the values of capital E1 and capital E2 in equation A. On substituting, we get EI is equal to R2 by R1 into E1 plus E output minus R2 by R2 E2 by R1. On simplifying, we get E input is equal to R2 by R1 into E1 minus E2 plus E output. We know the gain of the amplifier. the gain is A. The output voltage divided by the input voltage gives the gain. So E output by E input is equal to gain. The gain is now, this equation is written as E output is equal to gain into input. Now substitute the value of EI from here, 7th equation. On substituting, we get this equation E output minus E output into A. So A is equal to R2 by R1 into E1 minus E2. E output is taken as common. E output 1 minus A, and here A into R2 by R1, E1 minus E2. As the gain of the amplifier, it takes very large, minus A is taken as minus A. When comparing the value of capital A, 1 is very small. So the 1 is eliminated. So minus here. Minus E output into A is equal to A by R2 by R1, E1 minus E2. So the A is taken here, cancelled. So here R1 is equal to R2. So E output minus E output is E1 minus E2. The negative sign is taken here. So the E2 becomes here. So E output is equal to E2 minus E1. So to produce positive voltage, E2 should be greater than E1. So it produces an output signal which is difference between the two input voltages E1, E2 given at the two different inputs. One is inverting, another is non-inverting input of the operation amplifier. They are subtracted from one another. It is the operation of the difference amplifier or subtractor. So students, today we have discussed how the operation amplifier is used to average the different input voltages and how the operation amplifier used to subtract two different voltages. So okay, make the assignment and send it to me. Thank you.